Welcome, space traveler. Tonight, we are going on a journey far beyond the familiar comforts of our solar system. Close your eyes, take a deep, slow breath in, and let it out. As you release your breath, release the tensions of the day. The universe is vast, ancient, and deeply peaceful. In the grand tapestry of the cosmos, there are objects that challenge our understanding of reality, objects so heavy, so incredibly dense, that logic dictates they should simply vanish, collapsing inward forever to become black holes. Yet, they do not. They stand resilient, glowing softly in the dark. Tonight, we will uncover the secret of the neutron star. We will learn how a perfect cosmic balance holds the dark at bay, and how this ultimate cosmic stillness can help you find your own deep, unbroken rest. To understand the incredible resilience of a neutron star, we must first drift back in time to a period millions of years ago. Imagine a star, much larger and brighter than our own sun, burning fiercely in the cold vacuum of space. For eons, this giant star lived a life of perfect harmony. The crushing, inward pull of its own immense gravity was perfectly balanced by the outward push of nuclear fusion, the fires burning deep within its core. But in the universe, nothing lasts forever. Eventually, the star exhausted its fuel, the outward push ceased. In an instant, gravity took over, causing the star's core to collapse, while its outer layers were blasted into the cosmos in a magnificent silent explosion known as a supernova. What remained in the center of that glowing cloud of dust was the core, a sphere of matter so compressed, so altered by gravity, that it became something entirely new, a stellar remnant, a neutron star. Let us approach this ancient remnant in our minds. Imagine a perfect sphere hanging silently in the endless void. It is small, perhaps only 12 miles across, no larger than a quiet, earthly city. Yet this tiny sphere contains the mass of an entire sun. It is a masterpiece of cosmic compression. Just visualizing this perfectly smooth, perfectly silent orb can help center your thoughts, drawing your focus away from the sprawling worries of the day and into a single, peaceful point in space. But how heavy is this sphere, truly? Imagine reaching out and taking a single teaspoon of material from the surface of this star. Here on Earth, that small spoonful would weigh as much as Mount Everest, 1 billion tons of matter, resting in the palm of your hand. It is a density that stretches human imagination, a weight so profound that it bends the very fabric of space and time around it, creating a deep, invisible cradle in the cosmos. With such unimaginable mass packed into such a tiny space, we must ask, what happens to gravity? On the surface of this star, gravity is hundreds of billions of times stronger than the gentle pull that keeps us tethered to Earth. It is a crushing, relentless force, pulling everything inward toward the very center of the sphere. It is a gravity that wishes to crush this star out of existence, to fold it into a single, infinitely dense point. Here we encounter a common cosmic myth. Many believe that any dying star with immense mass is destined to inevitably become a black hole, an abyss from which not even light can escape. But the universe is a place of incredible nuance and resistance. Not every massive collapse ends in complete darkness. There is a hidden strength in nature, a microscopic defense mechanism that rises up to fight the crushing weight of gravity. To witness this microscopic defense, we must journey inward, beneath the smooth, glowing crust of the star. Imagine diving through layers of incredibly compressed iron, a metallic lattice squeezed tighter than any material on Earth. As we drift deeper, the pressure becomes surreal, dissolving the familiar shapes of atoms. The empty space that normally exists within atoms, the vast distances between electrons and the nucleus, is completely crushed. Everything is pressed together in a quiet, dark ocean of matter. In this deep interior, protons and electrons, the fundamental building blocks of ordinary matter, are violently fused together by the sheer weight of the star above. Imagine these particles merging in the dark, neutralizing each other, transforming into something incredibly stable and neutral. They become neutrons. The entire core of the star transforms into a vast, silent sea of neutrons, packed shoulder to shoulder. This brings us to the heart of our mystery. What is it that pushes back against gravity, What invisible shield keeps this ocean of neutrons from collapsing further? The answer lies not in the stars, but in the strange, fascinating world of quantum mechanics. It is a rule of the universe, a silent law of physics that dictates how the smallest particles are allowed to behave, a law that brings order and stability to the chaos of the cosmos. The Pauli exclusion principle. This is the name of our silent guardian. Imagine it as a cosmic rule of personal space. This principle states that no two identical particles like neutrons can occupy the exact same quantum state at the exact same time. They refuse to be squeezed perfectly on top of one another. They demand their own space, their own identity within the darkness. Think of a grand, cosmic game of musical chairs. As gravity squeezes the star tighter and tighter, the chairs, or available energy states for the neutrons, are removed one by one. The neutrons are forced to occupy higher and higher energy states just to avoid overlapping with their neighbors. They begin to move, to vibrate with a fierce, restless energy, purely out of necessity. This is not heat, but a quantum motion. This restless quantum motion creates something extraordinary. It creates an immense outward pressure, a force born entirely from the stubbornness of neutrons. This is known as neutron degeneracy pressure. Imagine it as a billion invisible hands, pushing outward against the crushing weight of the star's outer layers. It is a silent, epic standoff in the dark, a perfect balance of forces. On one side, we have gravity, the great sculptor of the universe, trying to crush the star down to nothing. On the other side, we have neutron degeneracy pressure, the quantum resistance of tiny particles refusing to yield. The two forces meet in perfect equilibrium. Neither side wins, and neither side loses. The star rests in a state of ultimate stability, a cosmic monument to the power of balance. This perfect standoff is a beautiful reminder for us. Just as the star finds balance between opposing forces, we too can find equilibrium in our minds. When the pressures of life feel heavy, trying to crush our spirit, there is always an inner resilience, a quiet strength pushing back, a natural balance that allows us to remain whole, stable, and at peace. Breathe in that strength and exhale the pressure. But quantum pressure is not the only hero in this story. There is a backup defense system, an even deeper force at play. Deep within the core, the neutrons are packed so tightly that they touch. At these incredibly short distances, another fundamental force of nature awakens. It is called the strong nuclear force. The very force that binds the nuclei of atoms together now steps in to hold up the entire star. The strong nuclear force is fascinating. At a certain distance, it is attractive, pulling particles together. But imagine squeezing those particles too close, pushing them uncomfortably tight. Suddenly, the strong nuclear force becomes incredibly repulsive. It pushes back with a ferocity that rivals gravity itself. It is a rigid, unbreakable wall, a final barrier against total collapse. Together, the quantum stubbornness of the neutrons and the aggressive pushback of the strong nuclear force create an impenetrable shield. Gravity pushes inward with the weight of a sun, and the core of the star pushes outward with the fundamental laws of nature. The result is a perfect sphere, hanging motionless in space, vibrating with silent, contained energy. However, even this ultimate shield has its limits. The universe is governed by thresholds. There is a specific mass limit, a point of no return, known as the Tolman-Oppenheimer-Volkoff limit. If a dying star is just slightly too heavy, if it crosses this delicate boundary, then not even the powerful neutrons can save it. Gravity will overcome the quantum pressure, and the star will silently fold inward, vanishing into a black hole. But the neutron star we are visiting tonight has not crossed that limit. It has survived. It stands proud and luminous, a testament to survival. Imagine its surface, incredibly hot, glowing with a soft, ethereal blue-white light. Yet, despite this intense heat, there is a profound sense of calm. The heat is trapped, slowly radiating away over billions of years, a slow exhale into the frigid vacuum of space. Let us shift our focus to the movement of the star. When the original giant star collapsed, its slow rotation was magnified. Just as an ice skater spins faster when they pull their arms in, the collapsing core began to spin with dizzying speed. Our tiny neutron star might be rotating hundreds of times every single second. Yet, because it is in a frictionless vacuum, this immense speed is completely silent, entirely smooth. Wrapped around this spinning sphere is an invisible web of energy, a magnetic field trillions of times stronger than Earth's. Imagine this field as vast, sweeping lines of force arching out into the darkness and returning to the poles of the star. This magnetic field is so powerful that it shapes the very space around it, acting as a cosmic engine, driving beams of radiation out into the void. As the star spins, these beams of radiation sweep across the cosmos, much like the beam of a lighthouse sweeping across a dark, stormy ocean. From Earth, we sometimes see these beams as rhythmic pulses of light, arriving with the precision of an atomic clock. We call these spinning wonders pulsars. They are the universe's metronomes, keeping perfect time in the deep silence. The rhythmic pulse of a pulsar is incredibly soothing. Imagine the steady, rhythmic beat, pulse, pulse, pulse. It is a heartbeat in the dark, a gentle reminder that even in the most extreme environments, there is order, rhythm, and predictability. Let the imaginary rhythm of this distant lighthouse sync with your own slowing heartbeat, guiding you deeper into relaxation. Beneath the surface of this spinning lighthouse, the star's crust is solid, a crystalline structure of strange matter. But occasionally, as the star slowly cools and its spin slightly decreases, the crust must adjust. It cracks. This is a starquake, an event of unimaginable power, yet completely silent in the vacuum of space. The star reshapes itself, finding a new, more perfect equilibrium. After a starquake, the star settles once again. The slight tremor passes, and the perfect sphere is restored. It is a lesson in letting go. Sometimes, tension builds within us, and we must allow ourselves to adjust, to release the pressure, and to find a new state of rest. Just as the neutron star settles, you too can let your muscles relax, sinking heavier into your bed. Let us imagine diving even deeper into the star, past the solid crust, into an exotic region scientists playfully call nuclear pasta. Here, the immense pressure forces the neutrons and protons to arrange themselves in bizarre shapes, first into long tubes like spaghetti, then into flat sheets like lasagna. It is a surreal, mesmerizing landscape, a testament to how extreme conditions create strange and hidden beauty. This strange, hidden architecture holds up the sky of the neutron star. It is a hidden foundation of strength, completely invisible from the outside. We, too, have hidden architectures of strength within us, layers of resilience and calm that we cannot always see, but which support us through the heaviest of days. Acknowledge that inner strength now and let it comfort you. As we drift back out from the core, breaking through the glowing crust and into the silent space surrounding the star, look back at the perfect sphere. It is a paradox of nature. It is the most violent, extreme environment imaginable, born from an explosive death, and yet it is the embodiment of absolute stillness, total balance, and eternal patience. It will sit here, spinning in the dark, for trillions of years, long after our sun has faded, long after our galaxy has changed its shape. This quiet sphere of neutrons will remain. It is a patient watcher of the cosmos. Its slow cooling is a process so drawn out, so gentle, that time itself seems to lose its meaning in the presence of the star. There is a deep, profound connection between this dense, distant star and the very atoms in your body. The heavy elements that make up the Earth, the iron in your blood, were likely forged in the fiery explosions that give birth to neutron stars. We are intrinsically tied to this cosmic dance. We are born of the stars, and we share in their quiet endurance. As you lie here, floating in your own safe space, imagine the invisible shield of the neutron star. The Pauli exclusion principle, the strong nuclear force holding back the dark. Imagine a similar shield around yourself, a soft, glowing barrier of peace that keeps out the stress, the noise, and the worries of the world. Inside your shield, there is only quiet. The standoff between gravity and quantum mechanics is settled. The star is safe. It will not collapse. It has found its permanent state of rest. Let your body find that same state. The forces of your day have perfectly balanced out, leading you exactly to this moment of stillness. Surrender to the balance. Surrender to the quiet, dark space behind your eyes. Our journey to the edge of physics is complete. We have witnessed the miracle of the neutron star, a beacon of resilience shining in the dark. We have seen how the smallest particles in the universe can stand up to the most crushing gravity, creating a perfect, eternal balance. As you drift closer to sleep, take this sense of balance with you. Know that just like the star, you possess an inner strength that keeps you grounded, stable, and safe. Your mind and body have found their equilibrium. Thank you for traveling with us through the cosmos tonight. May your dreams be as vast and peaceful as the deep space we have explored. Before you drift away entirely, consider this question to ponder in the morning. If you could visit any strange world in the universe, where would you go? Sleep well, space traveler, and good night.